So we're going to take a look at the 8th grade math unit coming up for volume and surface area. The volume and surface area unit is 13 days long, and in the 8th grade level involves 2 readiness teaks and 2 supporting teaks. The first of those readiness teaks, shown here in green, 8.7a, to solve problems involving the volume of cylinders, cones, and spheres. Now when we break that teak down, solve means pretty much what you expect, to work out the answer or solution to. The next phrase makes us have to think about it just a little bit more. We're going to solve problems involving the volume of, and we'll pause there because I've underlined the word involving. Reading there, involving the volume could mean finding the volume of it, or it could mean having to find other dimensions of the particular shapes. And those dimensions being height, radius of base, radius of sphere, area of the base, circumference of the base, etc. And the shapes specifically mentioned, and this is refined in 8th grade now, are cylinders, cones, and spheres. So there's no pyramids involved in this. And so the volume teaks just simply involve cylinders, cones, and spheres. Now pay note that those are all circular bases. So now all of a sudden we've got to make very sure that students understand pi in terms of 3.14 or 22/7, and also being adept at leaving answers in terms of pi. Now I mentioned there were 2 readiness and 2 supporting. The 2 supporting really fold into this readiness standard, and I've got those there just for comment right now. 8.6a is to describe the volume formula. V equals the area of the base times the height of a cylinder in terms of its base area and its height. So notice they're focusing only on the cylinder there and just trying to make sure that the students have a depth of knowledge of understanding where that dimensional measurement comes from, the area of the base. And then as well, 8.6b, to model the relationship between the volume of a cylinder and a cone, having both congruent bases and heights, and connect that relationship to the formula. So you're looking at the fact that that cone is 1/3 of a cylinder, and you can display that either pouring water into those shapes, or there are a number of videos out there. But that cone is 1/3 of that cylinder when they have the same height and the same base area. Or could twist that around and say that the cylinder is 3 times that of the cone. So they want to understand the connection between those two. I've thrown up those images there of those shapes that are required for the volume, just to get an idea when we say involving the volume. Clearly there are other dimensions, the height or the radius here shown of the cylinder, the radius of the sphere, the radius, even the area of the base of the cone, or the height of the cone. So be careful in your problem sets not to just be constantly finding volume, but to be challenging the students to work based on a certain volume or height, find the radius of the base. Mix and match those so that they are challenged to be able to work any of those problems forward and backwards, so to speak. And now the second of the 2 readiness readiness standards, to use previous knowledge of surface area to make connections to the formulas for lateral and total surface area and determine solutions for problems involving rectangular prisms, triangular prisms, and cylinders. I've split this on 2 slides because there are 2 main parts of that surrounding those 2 verbs. Use, to make use of, making use of previous knowledge of surface area. Now that previous knowledge in the new teak structure could be found in 7.9d in 7th grade, where the students determine the surface area, total and lateral, of rectangular prisms, triangular prisms, and some other shapes, but note, not cylinders. And they determine that by finding the area of the net. So that is specific now in 7th grade, that they find the surface area of those shapes using the area of the net. So that's what they're being asked in 8th grade to kind of make a connection to. Obviously, in this first year of new teaks, we'll have an issue there. But they're wanting to make connections to the formulas now for lateral and total surface area. So essentially, you're looking at what we tried to do in eighth grade before was to connect the net and the area of the net to the formula. Uh, Note here that students must connect what was done piecemeal using the net to the formula for the surface area. That's lateral and total. So when we had students do the area, the surface area by the net, they found the area pieces. Now they're looking at that formula and how it combines all that. Note this is not a net building TEK, but a net connecting or net referencing TEK. Now here's the second half of that TEK. I said it was based on a couple of real strong verbs. The first section there, to use, and the second one, to determine. So based on that previous knowledge, using that previous knowledge there, to determine, which would be to conclude or ascertain as after reasoning or observation. Determine solutions for problems involving, and there again is that big word, involving. Problems involving these shapes could mean surface area, the lateral, and the total, or any of the dimensions of the shapes mentioned. Again, just like the previous TEK that we looked at. But note that that surface area TEK is limited to rectangular prisms, triangular prisms, and cylinders. Now, if you're watching all the connections here, notice that cylinders are that common element that eighth graders find the volume to, as well as the total or lateral surface area of. Interestingly enough, it's also the shape that there will be limited background knowledge on the using the nets, because that's not going to be part of that TEK in seventh grade. And here I've included some of those images just again to reiterate the problems are involving surface area. So they could be total, lateral, or it could be a combination of trying to find one of the dimensions, whether it's the height of the cylinder given the surface area of the cylinder. The triangular prism has always been the difficult element in eighth grade. Could find the area of the base, or given the area of the base, find the height of the prism, or they could be given one of the dimensions of the base and the height of the prism and the surface area and have to get the height. So we're going to have to be very diligent and comprehensive in developing problem sets and assessment questions that will be able to cover the TEK at that level when it is so broad. So we'll have to make sure that we're covering and checking off if they can take the volume and find this, or the surface area and find this.